Okay, so we're going to continue where we left off in the previous video. If you remember, we came up with an equation, this y equals 2x plus 1, to identify how many partitions were needed for any number of faculty members. Right? We arranged them in this fashion. So if I wanted to figure out how many partitions were needed for 30 faculty, right, I could either draw this out for 30 faculty, or I could just put in the number 30 for x and solve for y being the number of partitions, right? So let's try this again, but now we're going to use horses, right? So if you look in Canvas, I have a folder or a handout that's called Handout 1, and it looks like this when you open it up. You could find this in Canvas. And I give you an example, right? Fred is setting up some type of show for horses. He needs to build 20 pens. And if you remember, I gave you an example of what these pens might look like. Let's see if I can find it. Right, it looks something like this. Right, these are the panels. Right, so if I wanted to do 4 for each horse, you can see I could do it kind of like a square. Right, 1, 2, 3, 4. And then just to show you what the panels look like. All right, they're flat. In this case, it looks like they're wooden, and they're used to hold our horses. So I need 20 pens. That says, how might he design and arrange the pens? Let's think about this. So I'm thinking one design could look like this, right? I could kind of draw a square, right, and put my horse in the middle. I can't draw very well. I'm going to pretend that's a horse. So that could be one pen for one horse. And that looks like it's 1, 2, 3, 4 panels. But then to get another one, a second horse, I only have to add 1, 2, 3 more additional panels. Right? 1, 2, 3. Right? So that's one design to handle my horses. Another design could be triangles. Right? I just need to make sure it's enclosed so the horses can't run away. Right? So in this design, there's no way the horse can get out of these pens. But also in the triangle design, right, if my horse is in here, it's still kind of locked in, right? And then, so I only need 3 panels to start, and then I just need 2 additional panels, right, for each horse, right? Every time I want to add another horse, I just need 2 more panels. So it looks like this design would require fewer panels. And again, I think I have a picture of this. Yeah. This looks much neater than what I tried to do. Right? See how the triangles, right? We add 2 more panels every time we want to add a triangle versus adding 3 more panels every time we want to add a horse. All right, so these are 2 options I could think of. How many pens will we need? Well, remember, we have to understand the problem, right? Come up with a plan. It says it right here. We need 20 pens. So the answer here is 20. And then the question is how many panels? So I'll call this design A and design B. So if we're going to go with design B, we can do an input-output table, just like we did in the previous problem, and then we can think about it. All right, so let me see if I can move this. So if I have 1 pen for 1 horse using the triangle design, right, I need 3 panels. And again, let's just show you, right? If I have just 1 horse here, I would need 1, 2, 3 panels, right? But if I had 2 horses, I would need 1, 2, 3, 4, 5 panels. So let's write that down, right? 2 horses would be 5 panels. And then what about 3 or 4 horses, right? 3 horses, you could just count the panels, right? 1, 2, 3, 4, 5, 6, 7. And every time we add a horse, we add 2 panels. 8, 9, 10, 11, right? So it looks like we're going up by 2s. And you can actually see it's written out for us here conveniently, right? Oops. There we go. 3, 5. So it looks like we start out with 3, but then we need 2 extra panels every time we add a pen. So that's why you see we go from 5 to 7 to 9. Okay, so I'll just write 7, 9. And without really thinking about it, you can kind of predict right, if we were to continue with our table, right, 5, 6, every time we increased pens by 1, the panels increased by 2, right? 5 to 7 to 9 to 11 to 13. It's just this first one, we start out with 3. So again, can you come up with a function rule, right? I'm thinking if this is x, and this is y, right? We had x and y. If I were to write y equals, because it looks like we're increasing by 2, if I just wrote 2x, it wouldn't work for this first case, right? If I were to write y equals 2, instead of x, I put in a 1 here, that would just leave me with 2, but I need 3. So I need to add maybe a plus 1. Now this would work, right? Y equals 2 times 1 plus 1, that would equal 3. So let me clean this up. I'm going to kind of clear this out and just start again, right? I think the rule should be y equals 2x plus 1 because we're increasing by 2. But for the first one, we needed 3. So if I write y equals 2 times 1 plus 1, or y equals 2 times 2 plus 1, or all the way down here, y equals 2 times 7 plus 1. Remember, the 7's coming from here, right? The 2's coming from here, right? The 1 is coming from x, right? I'm replacing what's in parentheses, the x, with the value from here to find my y. So when I do this, you say I get 2 times 1 is 2 plus 1 is 3. Here's 2 times 2 is 4 plus 1 is 5. And look, 3, 5, whoops. Right, here's the 5. So 2 times 7 is 14 plus 1 would be 15. Right, so it works. So the question is, what about 20 pens, right? If I kind of put a little ... 20, what would my value be for the number of panels, right? So I would have to enter y equals 2 times 20 plus 1 to get, what is this? 40 plus 1 is 41. Okay, so I would need 41 panels to house my horses, right? So going back to the original question, how many panels will you need? Well, if we do design B, we would need 41 panels. So I'll just type that in there, right? 41 panels. I'm going to write using B, right? The triangles. If we used letter A, that would be a different story, right? We'd have to redo because we'd start out with 1, 2, 3, 4, right? So you'd have to start out with the 4 down here for the output, and then it would increase by 3. Okay, but that's not what they asked us to do. All right, so that was just a little practice. Hopefully you found that reasonable. Okay, I feel like this is a pretty good quiz question, you know, or a test question. All right, let's get back to the book. I think in my next video, I'd like to maybe work through some practice problems. Let's see here. Yeah, on page 13, it says example 2, practice using input-output tables. Let's take a look at this in the next video. Thank you for watching.